Okay, in example 3, let's enhance the understanding of this concept of modulus elasticity, Poisson ratio, and shear modulus. Okay, so here is an 10.5 inch long alloy rod with an initial diameter of 3/4 inch is used in a tension test. After applying the tension force of 12.25 cubes, the length of the rod has increased 0.0325 inch, and the diameter has reduced 0.0006 inch. Determine the modulus elasticity and Poisson ratio if the material is within the proportional limit. Okay, this is a very straightforward calculations and not that hard. Okay, if you understand the concept, if you know how to use these equations, you can easily find out the results. Okay, so let's solve it. At the beginning, again, let's analyze this problem. Okay, so first of all, let's see what we are calculating. Determine the modulus of elasticity, right? That is the E. Right? Determine the Poisson ratio, that is our nu. Okay, what we have known, this is the load has been given. This is the F. Initial length is the L. Diameter is here, and had increased. That is the delta L. Right. So that is the delta. Delta has been given, and the reduction diameter has reduced. That is the deformation along the longitudinal, along the lateral direction. Okay, so we will see how to use it later. Okay, and you can see here we're requested to calculate E. Right, how to calculate E? Right, our equation is E equals sigma over epsilon. Right, so here we need to determine sigma. Right, how to calculate sigma? F over A. Right, how to calculate epsilon? Delta over L. Right, then we're also requested to calculate nu. Nu has been defined as negative lateral strain along lateral direction over strain along the longitudinal direction, or the transverse strain, negative transverse strain over the axial strain. Right? These are our definitions of nu. So we just need to determine those things, those strains along different directions. Okay. So here to solve the whole problem, we will have step 1, step 2, step 3, and step 4. Okay, we have 4 steps. Okay, step 1 first. What is our normal stress? So we are calculating the normal stress. Okay, we need to know the F and A. Right, so what is the F? F has been given, that is 12.25 kips. Right, and what is our A? We have known the diameter. Right, the A is just pi over 4 d square. So pi over 4 times 0.75 square. So we get 0.4418 square inch. And so this sigma equals F over A. Right, that is 12.25 kips over 0.4418 square inch. So we get 27.73. So what is the unit? What is the unit here? KSI. Okay, KSI. Then the second step, we're determining epsilon, right? So we need to know the delta and L, right? So what is delta? Delta here is 0.0325 inch. That has been given. Now what is L? 10.5 inch. Right? So the epsilon can be calculated as delta over L, 0.0325 over 10.5. Right? We get 0.003095 strain. So now we can come to the third step to calculate E, that is sigma over epsilon, right? 27.73 KSI over 0.003095 strain. So we get 8959 KSI, or 8.959. Oh, this is a KSI. Okay, we're not converting it to gigapascal. Okay. Okay, that is the third step. Then the last step, we're calculating the nu, right? So we need to know, since we have known that nu equals negative lateral direction strain over longitudinal direction strain, right? So we need to determine what is the lateral direction strain. What is that? We have known that the diameter, the original diameter is what? Original diameter is 0.75, right? And it's reduced 0.0006. 0.0006. So we can get 0.0008 strain, right? So this is the lateral strain. Is there any problem in this calculation? Sure, we missed what? We missed a negative sign, right? Since it reduced 0.0006, right? We'll get a negative strain. Then the longitudinal strain is what? It's we have calculated, right? It's here, right? 0.003095. Right, so this nu can be calculated. Don't forget the negative sign, okay? Although I have mentioned that we can create some negative Poisson ratio sign materials, but in this course, in mechanics of materials, never tell me you calculated a negative Poisson ratio, okay? That would be not possible. If you calculated the Poisson ratio and the result is a negative number, so you made a mistake, okay? You have made a mistake. So don't forget the negative sign here, right? Negative 0.0008 over 0.003095. Okay, the result is 0.258. Okay, we're done with these calculations. But if I ask you what is the shear modulus, right? You have calculated G and nu. So what is the shear modulus? Okay. We have introduced a equation, right? We have introduced the equation that will be used in later chapters too. Okay, the equation said G equals E over 2 times 1 plus nu. Okay, based on this equation, you can also calculate the shear modulus.